Good morning, students. Can you hear me? Shall I start today's class? Can you hear me? Okay. Last class, we have studied some important equations of two-cavity klystron, that is, output power, efficiency, voltage gain, mutual conductance, etc. Okay. And I had also gave you one problem as homework. Have you completed it? Have you completed that problem? Okay. I will explain that problem. Okay. Last class question. V0 is given. Okay, what is V0? What is V0? 10 kilovolt. Okay. And cavity gap is also given. D equal to 2 mm. Okay. And gap voltage V is equal to 100 volt. Okay. How to find uniform velocity V0? How to find it? How to find uniform velocity of electrons before entering the gap? Given values are V0 equal to 10 kilovolt. Okay, and V1 equal to 100 volt and D equal to 2 mm. Okay, and frequency F equal to 5 gigahertz. Okay, am I right? Am I right? Please respond. Okay, am I right? Okay, then we should find the uniform velocity of electrons before entering the gap. Okay, that is V0. Okay, we should find V0. How to find V0? This was the first equation. Okay, we have studied in this module. Okay, what is V0? V0 is 0.596 into 10 raised to 6 root of V0. Okay, okay. What is the answer of this part? What is the answer of uniform velocity of electrons? That is V0. When you substitute capital V0, please type it in your chat. What is the answer? What is the answer? Just substitute the value of V0 in this equation and solve for the uniform velocity V0. Okay. Have you completed this? Have you completed this much? V0. What is the value of V0? Just use your calculators and tell the answer. What is V0? V0 is what? 0.596 into 10 raised to 6 root of what? 10 into 10 raised to 3. Okay. That is 59.6 into 10 raised to 6 volt. That is what? 59.6. Okay. Have you written this? Have you got the answer of V0? Please respond in your chat. Okay. Numericals are important for the subject. Okay. For each and every question, there will be a numerical part. Okay. Okay. Next, what is transit time equation? Transit time equation. Transit time equation. What is transit time equation? Tau equal to d by v0. Okay. D by v0. Okay. 2 into 10 raised to minus 3 by 59.6 into 10 raised to 6. Okay. It is 3.355 into 10 raised to minus 11 seconds. Okay. This is the answer for transit time. Okay. Have you completed this? Have you completed this much? Okay. Next, we have to find what? Theta g. Okay. We have to find the transit angle. Okay. What is transit angle? Omega tau. We can write tau as what? Write omega as 2 pi f. We know omega equal to 2 pi f. Okay. Omega equal to 2 pi f and substitute for omega into tau. Okay. 2 pi into 5 into 10 raised to 9. It is gigahertz. Okay. We have to convert to hertz into 3.355 into 10 raised to minus 11. Okay. Which is equal to 1.054. What is it? Unit. What unit is it for theta g? It is radians. Okay. It is radians. Have you understood this much? Have you understood this much? Please respond. Have you understood this much? We have to convert this radians to what? Degree. How to convert it? It's not an ordinary degree. We have to convert it to what? Microwave degree. Okay. We have to convert it to microwave degree. Okay. It is microwave degree. Okay. The relation of degree and microwave degree, that is 1 microwave degree will be, sorry, 1 microwave radians will be equal to 57.29 degree. Okay. Please write this relation. Okay. 1 microwave radians will be equal to 57.29 degree. Okay. Apply it in this and convert this value to degree. What will be the value? What will be the value? Just multiply. Okay. 1.054 into what? 57.29. Okay. What will be the answer? It is 60.32 degree. Okay. Therefore, we got V0 as 59.6 m 1 minute. Okay. And transit time tau as 3.355 into 10 raised to minus 11, and theta g is what? 1.054 radians, that is microwave radians. And when we convert this into degree, we will get 60.32 degrees. Okay. Have you completed this much? Have you completed this much? Okay. Please write down next question. Okay. In a two cavity klystron amplifier, accelerating voltage V0 is equal to 2 kilovolt. Okay. And cavity gap D is equal to 1.5 mm, and frequency F will be 10 gigahertz. Okay. And signal amplitude. What is signal amplitude? The high positive value voltage. Okay. V1 equal to 100 volt. Okay. Find A beam coupling coefficient. Okay. Beam coupling coefficient. Okay. And B depth of velocity modulation. Okay. Please write down this question. I think you can find this value, beam coupling coefficient. Okay. Just substitute, it's just direct substitution. Okay. Have you written this question? Have you written this question? Please find the value of beam coupling coefficient. What is beam coupling coefficient? What is beam coupling coefficient? Beam coupling coefficient. This is beta I. Okay. We should find the value of beta I. Okay. For that, we have to find what? V0. Okay. V0. Okay. 2E V0 by m. Okay. This equation was there in velocity modulation derivation. Okay. V0, that is V0 equal to 2E V0 by m. Okay. By substituting it, what is the value? The same equation, 0.596, you can take it as 596 or 3. Okay, 3 into 10 raised to 6 root of V0. Okay. This step is the last step of velocity. That is first and foremost step of the velocity modulation derivation. Okay. Okay. Please remember this equation. Okay. Then substitute the value. Okay. This 0.593 into 10 raised to 6 into root of V0. What is V0 in this question? 2 kilovolt. Okay. You can write it as 2000. Okay. Therefore, it is 2.65 into 10 raised to 7 meter per second. Okay. It's velocity, therefore, meter per second. Okay. Next, we have to find out the transit time. That is tau. Okay. Tau equal to d by V0. Okay. That is, what is d? 1.5 mm. Okay. 1.5 into 10 raised to minus 3 by, what is V0? 2.65 into 10 raised to 7. Okay. What is the value of tau? What is the value? Calculate it and please write it in your chat. Okay. What is the value of tau? In seconds. Okay. In seconds, what is the value of tau? Equal to what? 0.566 into 10 raised to minus 10 seconds. Okay. Next, we have to find theta g. We have to find the value of beam coupling coefficient. Okay. What is beam coupling coefficient equation? Beta I equal to what? Sine theta g by 2 by theta g by 2. Okay. So we have to find out the theta g value. Okay. Okay. Therefore, what is theta g? Last question we have found out the same value of theta g. Okay, same equation, that is omega tau. That is 2 pi f into tau. That is, what is the value when substitution? 2 pi into 10 into 10 raised to 9 into 0.566 into 10 raised to minus 10. Okay, which will be equal to what? 3.55 radians. Okay. Finally, substitute for beta equation. Okay. Please write down the steps. Okay. This question is very, very important. All the questions are important. Okay. Beta I equal to sine theta g by 2 by theta g by 2. Okay. Therefore, sine, what is theta g? It is 3.55 by 2. At least type the answer in your chat. Okay. 3.55 by 2. Okay. What is the answer of beta I? What is the answer of beta I? It is 0.553. Okay. Therefore, we have got the value of beta I as 0.553. Have you completed this part, beam coupling coefficient? Have you completed this much? മനസ്സിലായോ എല്ലാവർക്കും ഇത്? In first question, we have find out what? V0.
ടീച്ചർ ടീച്ചർ കഴിഞ്ഞ ക്വസ്റ്റ്യനിൽ ടീച്ചർ V0 കണ്ടിട്ട് 10⁶ മാറ്റിയിട്ട് മില്ലി വോൾട്ടിലേക്കല്ലേ മാറ്റീന്?
ഒരു സെക്കൻഡ്.
മില്ലി വോൾട്ട് മെഗാ വോൾട്ടിലേക്കല്ലേ മാറ്റീന്? മീറ്റർ പെർ സെക്കൻഡ് അല്ലേ?
ശരിയാണ്, മീറ്റർ പെർ സെക്കൻഡ് ആണ്. നിങ്ങൾ കറക്റ്റ് ചെയ്തോണം കേട്ടോ, നിങ്ങളും കൂടെ ചെയ്യാൻ വേണ്ടിയിട്ടാ. മിസ്റ്റേക്ക് കണ്ടിട്ട് നിങ്ങൾക്ക് മനസ്സിലായില്ലേ ഇത്? മീറ്റർ പെർ സെക്കൻഡ് ആണ് യൂണിറ്റ്. ഓക്കെ, മനസ്സിലായോ അഭിജിത്തെ? Therefore, in first question, we have find out V0, that is velocity of electron beam. Okay. Then tau, transit time. Then theta g, transit angle. Okay. These three questions are always asked for exam. Okay. Next one, from these questions, that is from this three expression, that is ഈ മൂന്ന് എക്സ്പ്രഷൻ നിങ്ങൾ പഠിച്ചു വെച്ചാൽ എന്ത് നമുക്ക് ചെയ്യാൻ പറ്റും? ബീം കപ്ലിംഗ് കോഎഫിഷ്യന്റ്. ഓക്കെ, you can find out beam coupling coefficient. Okay. Have you written this much? Please ask if there is any doubt. Okay. Therefore, we have find out the value of beta I. Okay. Next is the depth of the velocity modulation. Okay. Depth means what? What do you mean by depth of velocity modulation? Depth of velocity modulation. What is depth of velocity modulation? It indicates how much the signal have been modulated. Okay. Okay. ആ സിഗ്നലിനെ എന്തുമാത്രം മോഡുലേറ്റ് ചെയ്യാൻ പറ്റി? This is called depth of velocity modulation. Okay. What is depth? Please write down the equation of depth of velocity modulation. Okay. Depth of velocity modulation can be found out by beta I into V1 by V0. Okay. It is beta I into V1 by V0. Okay. This is the equation of depth of velocity modulation. Okay. Please write this equation. Okay. Then substitute it 0.553. Okay, we got the value of beta I as 0.553 into what is V1? 100 by 2000. Therefore, what is the depth of velocity modulation? It is 0.027. Okay, have you written this much? Have you completed this question? Have you completed this question? എല്ലാവരും എഴുതിയോ ഇത് ഇത്രയും രണ്ടാമത്തെ ക്വസ്റ്റ്യൻ? Okay, we will move on to next question. Okay, please write down correctly. Okay, next is question 3. In a two cavity klystron amplifier, accelerating voltage V0 equal to 1.2 kilovolt. Okay, and also cavity gap D is what? 1 mm, and frequency F is what? 9 gigahertz. Okay, and also signal amplitude V1 is 80 volt, and the drift region length. Okay, that is length of drift space. Okay, drift region length L will be equal to 5 centimeter. Okay, you have to find first part, drift space, that is drift space DC electron transit angle. Okay, you have to find out first part, drift space DC electron transit angle. Okay, and the second part is bunching parameter. Okay, bunching parameter. Okay, please try this problem. Okay, please try this question. You have to first find out V0. Same equation, 0.593 into 10 raised to 6 root of V0. Okay. Okay, please find out V0, velocity of electron beam. What is the value of V0? What is the value of V0? V0 is what? This is the complete equation. Okay, 2E V0 by M. This can be written as what? 0.593 into 10 raised to 6 root of V0. Okay. Okay, just substitute the value of V0. Okay, this can be written as what? What is V0? 1.2 kilowatt. Okay, therefore 0.593 into 10 raised to 6 root of, we can write 1.2 kilovolt as what? 1200 volt. Okay, 1200 volt. Okay, Therefore, we will get 2.054 into 10 raised to 7 meter per second. Have you completed this part? V0. What is V0? 2.054 into 10 raised to 7 meter per second. Okay. Next, we have to find out transit angle. Okay. In this question, we will find out transit angle in another way. Okay. We can write transit angle, that is theta 0 as what? Omega t0. Okay. Also, we can write t as omega L by V0, because what? This L, that is value of L, that is drift region length. L is given. We have to find the angle of what? Drift space. Okay, we have to find the angle of drift space. So we have to write this equation. Okay, theta 0 equal to omega t0 equal to omega L by V0. Okay. Okay. What is omega? 2 pi f L by V0. Okay. L by V0. Okay. Substitute all parameters. 2 pi into what? 10 into 10 raised to 9. Okay. Sorry. 10 allala. 9. Alle. 9 gigahertz alle. Into what? 5 into 10 raised to minus 2 by 2.054 into 10 raised to 7. Okay, what will be the answer? What will be the answer? 152.9 radians. Okay. Have you got the value of theta 0? That is angle of drift space. Have you completed this much? Shall I move to next part, Bunching parameter? Please respond. Okay. Next, we have to find the value of what? Bunching parameter. Okay. Bunching parameter. What is the equation for bunching parameter? Bunching parameter X. We have written this equation a number of times, okay, in last class, for finding value of output power, efficiency, substitution, etc. Okay. X equal to what? Beta I V1 theta 0. We have taken theta 0 because of the drift space. We have to find the value in the drift space. Okay, 2V0. Okay. This is the equation for bunching parameter. Okay. For this, first we have to find the angle, transit time tau. Okay, d by V0. The earlier equation itself. We have done this we have seen this expression last two questions also. Tau equal to d by V0. Okay. 1 into 10 raised to minus 3 by 2.054 into 10 raised to 7. Okay. What will be the value? It is 0.486 into 10 raised to minus 10 seconds. Okay. It is 0.486 into 10 raised to minus 10 seconds. Therefore, we got the value of tau, that is transit time as 0.486 into 10 raised to minus 10 seconds. Okay. Then we have to find the gap angle. Okay, cavity gap transit angle. Cavity gap transit angle. Okay. theta g. Theta g will be omega tau, which can be written as 2 pi f tau. Okay, substitute then 2 pi into what is f? 9 into 10 raised to 9 into 0.486 into 10 raised to minus 10. Okay, this 2.75 radians. Have you completed this much? Theta g. Have you completed this much? Okay, so we got the value of theta g as what? 2.75 radians. Okay, then we have to find out the value of this beta I. Okay, beta I is sine theta g by 2. Okay, sine theta g by 2 by theta g by 2. Okay, sine 2.75 by 2 by 2.75 by 2. Okay, therefore beta I will be what? 0.715. Okay, 0.715. So finally we can find out the value of what? Bunching parameter. Okay, therefore bunching parameter x equal to beta I v1 theta 0 by 2 v0. Okay, this is the equation for bunching parameter. Okay, after substituting the value of beta I v1 theta 0 and v0, that is 0.715 into 80 by 2 into 1 to 2 into what? 1000. It is 1 kilovolt, 1.2 kilovolt. Okay, so 1200 into theta 0 will be 152.9. Okay, then the bunching parameter x will be 3.64. Okay, have you understood? Have you understood this much? Please respond. Have you understood this much? Okay, so you have to memorize or you have to study carefully this equation. Okay, this is very important. Okay, along with the derivations. Okay, derivations, that is I think there are 4 to 5 derivations. Okay, you have to study all derivations, and also please stressfully study this equation because problems are important. Okay, v0 tau theta g. Okay, these equations please write it in your note. Okay, all questions you have to complete it in your notes. Then beta I equation. Okay, this has very simple equations. Beta I is sine theta g by 2 by theta g by 2, and also please make a note on depth of velocity modulation. What is depth of velocity modulation? Beta I into v1 by v0. Okay, then this is very important, this question. Okay, also this equation for bunching parameter. Okay, bunching parameter x. Okay, please study these equations. Okay, so we will move on to next. Have you completed this much? Have you completed this much? Please write this equation. Okay, so direct substitution, you have to find out efficiency, voltage gain, etc. Okay, please write down this equation and do it as homework. Okay, we completed till question number 3. Okay, please write question number 4 and do it as your homework. Okay, this is very important. This is essay question. Okay, and an identical two cavity klystron amplifier operates at 4 gigahertz. Okay, with V0 equal to 1 kilovolt. Okay, and I0 equal to 22 milliamps, and cavity gap D is 1 mm, and drift space length L will be what? 3 centimeter. Okay, if DC beam conductance G0 equal to 0.25 into 10 raised to minus 4 Siemens, and total conductance Gm equal to 0.3 into 10 raised to minus 4 Siemens, and calculate what? Calculate V0. What is V0? Beam velocity. Beam velocity V0. Okay. Second is transit angle. Transit angle theta G. Okay. And beam coupling coefficient beta 0. Then input cavity voltage for maximum output voltage or gap voltage V1. Okay, then voltage, gain, and finally efficiency. Okay, please write down this question. Have you completed this? Have you completed this question? Okay, please write one more question. Okay, in two identical cavity Klystron amplifier, accelerating voltage V0 equal to 1 kilovolt. Beam voltage I0 is 20 milliamps. Cavity gap D is 1 mm, and frequency F is 8 gigahertz, and drift region length L is 4 centimeter. 4 centimeter. Okay, and shunt equivalent shunt resistance RSH equal to 40 kilo ohms. Okay, you have to find electron velocity, B gap, transit time, and C input voltage for maximum output voltage. Okay, and D voltage gain in decibel. Okay. And finally, maximum efficiency. Okay, have you written this question? Have you completed this question? Have you completed this much? എഴുതിയോ എല്ലാവരും? അഭിജിത്ത് എഴുതിയോ? ഓക്കെ. അറ്റൻഡൻസ് അഭിജിത്ത്, അനുവിന്ദ്, അപർണ, അർച്ചിത, അരുൺ, അശ്വിത, ചന്ദ്രലേഖ, ഗോപിക, ഹർഷ്, ഹിഫ്സു, മുഹമ്മദ് ജസീം, പാർവതി, രോഹിത്, വൈഷ്ണവി, അശ്വിൻ രാജ്, ദീപ്തി, ഹരിത, സനില, ശിശിര, സൗമ്യ.